Hey everybody, welcome to the Old West. We're going to take a look at proportions with some help from our good buddies Wyatt, Earp, and Doc Holliday. Enjoy the show. Yeehaw!
Hello, Wyatt. Good to see you again. How you been? Say, I got a little business proposition for you. How about you and I go on a little gold mining business? What do you think? Shoot, Doc. We ain't got time for that. I'm trying to run tombstone around here. I said no. Boy, you is a persistent one. All right. You talked me into it. Let's do this. Let me do all the planning on this, Wyatt. You just sit back and stay comfortable. I'm your huckleberry. We're going to hire some mangy dogs, and these scoundrels are going to do all the mining and panning for us, and we'll just watch all that gold come rolling into us. We'll take the majority of the split, throw them dogs some pennies just to keep them satisfied, and we'll be rolling. There's our prize, my friend. Pure, solid gold.
So here's the shakedown. For every 5 pounds of gold that's found, I'm going to take 2 pounds, Wyatt, you'll take 2, and those dirty, rotten scoundrels will get 1. We're going to be rich. Yeehaw! Yeehaw! So what does this have to do with proportions? If Doc, Wyatt, and the dirty, rotten scoundrels split up their gold in that way, what does this have to do with anything? Well, let's pretend for a second, instead of 5 pounds, that they're finding 10 pounds of gold. How would this be split between the 3 people, or groups? Well, 2/5. If we double the amount of pounds, we would double the amount of the take. 5 times 2 is 10, and 2 times 2 would be 4 for Doc. The same goes for Wyatt, and for the dirty, rotten scoundrels, 5 times 2 is 10, so 1 times 2 would be 2. So what we've created here are proportional fractions, or we could call those equivalent fractions. And what equivalent fractions are? When you have 2 of them set equal to each other, this is what we call a proportion. That's a proportion, that's a proportion, that is a proportion. So, what is a proportion? What makes something proportional? As we just saw in the last slide, when fractions are equal to each other and they are equivalent, we have a proportion. So in fact, any set of fractions or ratios that are equal to each other, that's considered a proportion. All 4 of these examples are considered proportions. They have fractions that are equivalent to each other, and you can see that by finding the factor number that makes one become the other. So in the first 3, I can see that they're all equivalent. There is a factor that makes the first fraction become the second. They're equivalent, therefore it's a proportion. So looking at the last example, if we go back to the gold mining examples, if the dirty, rotten scoundrels are supposed to get 1/5 of the gold, 1 pound out of 5, that means it should be proportional. If there was 10 pounds, then they should get 2 pounds of the gold, 2 pounds of the take. And you can see that there is a scale factor of 2 going from the 1/5 to the 2/10. So at this point, I'd like to talk a little bit about a little trick that you can use. So let's say we didn't want to try and use these scale factors, or we couldn't figure them out, what those scale factors are for making one fraction become the other. There's another little thing that you can look at that could be very helpful when trying to determine if something is a proportion, and if you know it's a proportion, how you can find maybe missing numbers within the proportions. So here's the interesting relationship with all proportions. If you examine the cross products of the numbers within the proportion, 1 times 4 is 4. 2 times 2 is also 4. The cross products are the same. 3 times 12 is 36. And so is 4 times 9. 3 times 8 is 24. And so is 2 times 12. So all the cross products within proportions should be exactly the same. So we'll see how this can be a usable idea moving forward. But that is a quick, easy way to check to see if something is proportional. So a quick check on proportionality. If you have a common scale factor going across the top and bottom, then you have yourself a proportion. Or if your cross products are equivalent, then that's also another way to check to see if you have a proportion. So let's test out 3 potential proportions here and see if in fact they are. The first one, there is a scale factor of 3 going across the top and bottom, which makes this a proportion. Or 4 times 21 is 84, and 7 times 12 is also 84. So yes, this is proportional. 2 ways prove this. The second example, I can't see quite exactly what the scale factor is going across the top, going across the bottom, but through the cross products method, I can see that 6 times 10 is 60, and so is 4 times 15. So I know that yes, that is a proportion as well. The last example, we can see that this is not going to be proportional because 3 times 2 makes 6 and 7 times 3 makes 21. There's a different scale factor going on there. Or 3 times 21 is 63, and 7 times 6 is 42. Those are not equal. So no, this is not a proportional relationship, and these fractions are not equal to each other. So the first 2 examples have fractions that are equal to each other, as proved in 2 different ways. And the third example has 2 fractions that are not equal to each other, so therefore that is not a proportion. So let's head back to the gold mine and check back in with Doc Holliday and see how honest of a businessman he really is.
Ike Clanton. Long time, my friend. I'd say it's good to see you, but I'd be lying. I thought Wyatt and I left you for dead in Tombstone. So I rode all the way up here because I heard that you found me some gold. I also understand that the miners and panners have made you their representative. Forgive me if I don't shake hands. So let's sit down and hash this out to see how much gold you're entitled. Hopefully you'll know your proportional relationships.
So let's see here. We found 60 pounds, according to your records. And our agreement, Wyatt and I each take 2/5 of the fine, leaving you dogs with 1/5. So, according to my calculations, Ike, that leaves 25 pounds for both Wyatt and myself. And you guys can split the last 10 pounds. Sound good? Yeah, Doc, that sounds real good. Sounds real good, Doc. So we should be able to see that this is not proportional. This is not proportional to the agreement that was put in place, that every 2/5 of the pounds should go to Doc and Wyatt, and 1/5 of the pounds goes to the dirty scoundrels. Check it out with cross products and you see 2 times 60 is 120. 5 times 25 is 125. That's not a proportional relationship. 5 times 10 is 50. And 1 times 60 is 60. That's not a proportional relationship. So therefore, this is not a fair deal according to the agreed upon contract. So what should it be? Well, we can easily figure this out based on a scale factor of 12. 5 times 12 makes 60, so 2 times 12 makes our answer appear. Both Doc and Wyatt should be getting 24 pounds of gold, and the dirty scoundrels should be getting 12. Oh, Ike, I was just messing about. Of course I'm going to give you the 12 pounds of gold. I couldn't bear it if we were not friends. So now, are we friends?